other stuff later. And we are officially recording. And now I could do my little share screen, which is this guy right here, at the old share schmear. And I will move you guys over. And remember, you can annotate everything. So just make sure that you start annotating and all that. So whoever was group 1, start filling this out. Please note that in this column right here, I want the inverse of the function. And then over here, I want the asymptote. And then down below, I want the graphs of those particular functions, okay? So everybody start going up. Remember, if you go to the top of the screen here, you can hit annotate and you can start writing. So I'll wait for you guys to fill all that in. Let's get going.
Oh, shoot. How do you annotate it?
Should I do the inverse on the same graph or a different graph?
Same graph.
I'm sorry.
Oh, here she is. Okay. Okay, filling this out. It's so hard when you don't have a pen, isn't it?
Mm-hmm.
Uh-huh. If you want, I can actually make this a little bit bigger. Hold on. All right. Whoever put this as your asymptote for number 2, I don't know if I agree with that. I don't know if I agree with that. And I'm going to, whoever has number 1, you didn't look like you had a lot of space there. So I'm just going to write it out a little neater so everybody can see it a little bit better, okay? So you have log base 3 of x minus 11 minus 6, right? Okay. All right, I'm okay with this one. I like that one. This one over here, I'm not so sure. If it's 64? Mm-hmm. And then the equation for number 2, I'm a little, where is the inverse for that one? Yeah, I agree with that. That's good. And then where's the asymptote for this one over here? Okay. Just waiting for this one to get filled out. And number 3, I'm not sure what's going on with number 3.
The red's the inverse and the blue's the original.
They don't reflect over the line y equals x, so I disagree.
Wait, let me fix it.
So number 3, I don't like it. I don't like your graph because remember, you'll always know that a function and its inverse are always going to reflect over the line y equals x. And that's always going to be one of those things where you'll know if you graphed it right or not. And the thing is remember, you can plot points on this function and then you know the inverse is going to have the x and y switched. Okay? This over here, the equation of the asymptote on number 2, this is not x equals 0. It should actually be,
Oh, y equals.
y equals 0. Thank you. So this should be y equals 0. Good, good, good. So a couple of things to analyze, which is nice. 3. Okay, I like that. Okay, that's much better. And remember, always put arrows at the end of everything, you guys. Get a little lazy in your old age, so just make sure we put arrows here where they're supposed to go. All right. Yes, thank you. And again, your arrows and your arrows. All right, so one of the things that I want you guys to observe is that, check it over here, that the equation of your asymptote is, if it's exponential, it's a horizontal line. But then when you find the inverse, it becomes a vertical line, and noticing that if it's y equals 11, then it's going to be x equals 11. The same old thing over here, if y equals 0, we'll check it out, x is equal to 0. And then here we have x equals 0, y equals 0, and so forth. So if we have x equals -4, then we get y is equal to -4 over here. Now, something that I want to allude you guys to is that if you look at this, before we do that, I'm going to go to a new page, and don't worry about all this stuff over here. I'm just going to play right in this spot here. I asked 2 groups to say, how come this does not exist? How come you can't do log base of a negative number? How come that's never, ever, 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 ever possible?
If you do the inverse of that, it would be -4 equals 2 to the x.
Right.
Doesn't work.
Right, because no matter what, like if I were to write this in exponential form, I would have 2 to the x is equal to -4. 2 to what power is going to give me -4? So if I were to say, okay, 2 to the 0, 2 to the -1, 2 to the -2, 2 to the 3rd, or whatever, 2 to the 0 is 1. 2 to the -1 is a half. 2 to the -2 is a 4th. 2 to the 3rd is 8. So in other words, this number is always positive, which means it will never, ever be a negative number. And it kind of makes sense when you're doing an exponential function, because exponential functions are asymptotic to the x-axis, which is why that's happening. So when we have a to the x, this is always going to be greater than 0. Regardless of what we put in for x, it's always going to come out to be a positive number. So that's why we can never do the log of a negative number. So now, when I go back to my page, whoops, over here, when you guys had this over here, the interesting thing is if you look at this guy, the domain of this has to be x is greater than 4. Because the other thing I want to point out, does this exist? Can I get this value?
No.
No, because again, if I write that, I'm going to have 2 to the x is equal to 0. When is 2 to some power going to give me 0?
Never.
Ever.
It never does. It never, ever, ever will. So that's why when we're thinking about it, the domain of that's why the domain of this has to be anything bigger than 4. So when you're graphing this function, which is this guy right here, this is the line x is equal to 4 down here, because it's asymptotic to that, because I need, this has to be positive. So in order for that to be positive, this has to be greater than 0, which is why x has to be greater than 4 for that one. And then similarly, this guy right over here, it's got to be greater than 0 for that guy. Has to be greater than 0 for that guy, which is this guy right here. So this is your log function, and then this right here is your exponential function, because this has to be positive. Okay, so those are really fun things that I wanted you guys to think about as we're doing this. And then we're pretty much done, but I just want to ask a question. If I'm going to stop